Okay, so for today's deep dive, we're looking at a piece of gear that's probably the definition of an unseen hero in pro audio.
Absolutely.
We are cracking open the technical specs for the DBXBOB-V. It's a wall-mounted breakout box.
Yeah, it looks like a really simple hub, but it is such a critical link in the chain. Our mission today is to show you, the listener, how this seemingly mundane box gives you so much extended control.
For the drive rack and zone PRO families.
Exactly. We're going to unpack how it turns just, standard cheap cable into some really sophisticated audio logic across huge spaces.
The first thing that jumps out at me is just the scale of it. It supports 9-zone controllers, and it does it all with off-the-shelf CT5 cable. But, I mean, if it's that simple, where's the real magic here?
Well, the magic is that they chose not to make it complex. The core mechanism here, and this is what's so fascinating, is that the zone controllers don't use digital packets. They don't need an IP address.
Okay.
They use simple analog DC voltage. That's it. That's how they provide the logic control.
Wait, just DC voltage. How does that manage complex audio commands? That sounds incredibly basic.
Think of it less like a computer network and more like a very precise dimmer switch.
Okay.
The controller just varies the DC voltage on the wire. And the main unit, the drive rack or zone PRO, it just reads that specific voltage level as a command.
So like 5 volts means one thing and 3 volts means something else.
Precisely. It could be volume level 3, or it could be selecting source B. It's a principle based on varying electrical resistance, which is just inherently simple and, super resistant to network conflicts.
And that simple analog signal translates into some really mission-critical functions.
He does.
I mean, we're talking about more than just volume. The specs say it handles zone source selection, program changes, and this is the big one, fire safety muting.
Yeah, that's crucial.
How can it reliably guarantee something as important as a fire safety mute with just a simple voltage change? You'd think you'd want like a modern digital handshake for that.
See, that's the strategic choice. The simplicity is the reliability. Because it's not relying on a complex software stack or a processor that could crash. The risk of failure is just dramatically lower. It's low-level signaling that's designed for immediate guaranteed action. That's why contractors trust it.
That makes perfect sense. And I guess it simplifies the install side, too.
100%.
Using readily available CT5 or CT5E, with those RJ45 connectors everyone knows, it means any licensed electrician can run the line right, not just a specialized AV tech.
Exactly. It just slashes the installation cost and the complexity. But the real engineering challenge this box solves is distance.
Right. The specs for the cable runs are genuinely impressive. For a big convention center or something, this is key.
It
The
is.
source notes that with parallel wiring, which you do need the ZCBOB for that, you can get up to 1,000 feet for 6 zone controllers.
That 1,000 feet is an amazing feat for analog control, but you have to plan for it. If you look closer at the specs, you see the trade-offs.
What do you mean?
Well, if you choose to do series wiring, daisy chaining them, that maximum distance just plummets.
Oh, wow.
Yeah, it's like 600 feet for just 3 controllers, and it drops to only 300 feet if you try to string 6 of them together.
So why is there such a huge difference between series and parallel?
It just comes down to physics, really. You have to have enough voltage to power the controller at the very end of that long line.
High voltage drop.
Distance equals resistance. It's that simple. To hit that 1,000-foot mark, the cable spec is critical. You have to use CT5 or CT5E with 28.6 ohms per 1,000 feet nominal DCR.
DCR, so DC resistance.
Yep. If your resistance is too high, the voltage drops too much. The controller at the far end might only see 3 volts instead of the 5 it needs, and then your controls get all wonky or just stop working. Parallel wiring just mitigates that drop much, much better.
So when you pull it all back, what you have is this compact box. It costs about $140, and it's built for absolute resilience. It's even TAA compliant, so it meets U.S. government trade requirements, and it has key safety certifications like UL 630 or 65. It's made to be globally reliable.
It is. It's extensive, it's flexible, and it gives you distant analog control over these complex audio systems using infrastructure that is simple, cheap, and, everywhere.
It's a solution engineered to avoid failure.
Not just to handle data, exactly.
So I guess that leaves us with a final thought for you, the listener, to chew on.
What does this continued reliance on simple, long-range DC voltage control, where, low cable resistance is the #1 priority, what does that tell us about the real priorities in high-stakes commercial systems? It seems reliability trumps pure data speed. It's a fascinating constraint, something to consider the next time you see a standard RJ45 jack in a wall and wonder what precisely is running through it.